Okay, so we've got, let's go straight to the simulation then. So we've got on this simulation, we've got, well, we see it better in the whiteboard, actually. There's light coming from a source. That light is meeting two slits, and then it's producing this pattern. We'll try to understand why that's happening. If we look on the double slit, we can see with one wave, you can see the waves that are spreading out in circles, and the same with the one below, and that is and they're going to interfere with one another. Now, if we pause it for a moment, you can see these dotted lines are showing where the maxima are. Okay, so the reason for that is because the wave fronts are touching at that point. So if we imagine the wave fronts are maybe the trough or the, no, let's say it's a peak, but it doesn't really matter actually. It means at that point they're in phase with one another, and of course, because they're originally the same wave source, then they're going to be the same frequency. So they're going to be in phase, and so you're going to have constructive interference at those points, at these dotted lines. I can turn off that, and you can still see the dotted line. You can still see where it's going to intersect, but the dotted lines just sort of give you the answer. Yeah. So just pause the video for a moment and we'll have a look at something else. So over on by clicking show interference pattern, we've got a kind of picture of if this was these are light waves, then this is kind of what you would see on the screen here. You'd have this bright fringe and another bright fringe and another bright fringe wherever the constructive interference is occurring. Oh, I don't know why it suddenly reset then, but that's pretty cool. So you can see. That wouldn't be bright then because the light hasn't actually reached it yet. But anyway, okay. So let's have a look at another one. So this is looking at the same experiment, but now we're focusing just at one place. If we go back to the previous one, what we're looking at is this first. Hang on a second. So what we're going to be looking at, we're going to focus on this point here. Okay. So at the middle, we've got the waves from the center point going to the middle point, and then there they've constructively interfered again, and they've also constructively interfered there and there. But anyway, so we're just going to focus on that one compared with that one. All right. Okay. So we've got the wave coming from one slit over here and the wave coming from the other slit over there, and we know they're constructively interfering, and so when we go from all the way from here to there compared with from here to there, by the time they get to this point, a crest is meeting a crest. Okay, so it's constructively interfering. Now, if we think about what must have happened, is that if I pause it, I just need to choose that. So if I just pause that, the difference, what we call the path difference, which means the difference, the extra distance that this red wave is traveling compared with the green wave, is going to be a total of one wavelength. The reason why it's a total of one wavelength is that at this point here, then they're going to be one's going to be going to the middle point, the other one's going to be going to the middle point. They both would have traveled the same distance. You can see up here that the green would have not have to travel quite as far as the red, but it's also the next place that they're constructively interfering. The bits in between this point here and that point there, they weren't constructively interfering, and so the path difference must have been less than a wavelength. Now the path difference is exactly one wavelength because they're constructively interfering once again. If I were to go to the next point up, the next constructive interference, then the path difference would be two wavelengths. So we'll just stop that video there because it's going to chop it off anyway. So I'll stop there.